So welcome to the Target of Opportunity workshop. This is going to be sort of a low-level look at resources, current procedures, and future for target of opportunity observing. So looking at the nuts and bolts and doing some demonstrations. So it'll be a mixture of presentation and demonstration, some of which you may be able to follow along if you have a Python environment ready to go. Other logistical things, keep putting your questions into the HOVA chat, Q&A chat room, and we'll stop occasionally to look at those. I will not be able to answer any questions right now about individual problems with running the software. I'd be happy to follow up with people afterwards about that. Okay, so converged, and I'm participant, so we'll get started. So as most of you are well aware, for most Gemini programs, the targets have to be included in the proposal. They're approved by the NTACs, and then you need special approval to add any new targets to your program. But with the ToO, or Target of Opportunity mode, the coordinates of the targets are not known at the time of the proposal, or the time that your observation needs to be scheduled can't be specified. For example, you're monitoring some source that needs to change state, and then you want to get spectroscopy of it when it changes state. So this ToO mode, of course, is useful for time domain astronomy, but it's not necessary, as I mentioned, and you may be waiting for optical survey to get some galaxy targets, for example. So it can be used for a wide variety of things. So you have to apply for this special mode and then get that approved by the NTACs instead of the exact targets in your proposal. So I will go through the two main flavors of target of opportunity observations. One are the rapids, which have to be observed in the next 24 hours, usually for that night or the night that's coming up. Because these are high priority observations, they usually need to be put in band 1, the highest ranking band, and they can't have any condition constraints. If there are any condition constraints, the chance of being able to observe at any given moment would be very, very low. It is possible to interrupt ongoing observations. Doing this back in the days of following up gamma ray bursts, the fastest time from receiving the trigger to start of science was about 6 minutes. So it can be relatively quick. You do need to specify in your proposal if you need to do this so that you can get approval for this particular mode. And if you do this, your program might get charged for any time lost to the program that you're interrupting, just so you know in advance. The other flavor of ToOs are the standard ToOs, which can be basically scheduled almost at any time after the trigger. It's usually for the next natural plan. It might be for the coming night if you submit the trigger early enough in the day, but there's no big urgency. You can set timing windows, usually days to months. And if you do a standard ToO follow-up of a rapid, then you need to have conditions better than any. It is possible to do standard ToOs with LGS, but you need to submit your trigger at least 4 days in advance so we can go through the process of the laser clearinghouse approvals. Now, instrumentation, all the facility instruments really can do ToOs, but the workhorse instruments, which are almost always mounted to the telescope, are the most useful. In the optical, of course, that's the two GMOSs. In the infrared, that's GNIRS and Flamingos 2. For GMOS, it does have exchangeable components, especially the gratings. So the most useful for ToOs tend to be the B600 and R400 because they're almost always in, and it's the third slot that gets swapped out between like the R150, R831 gratings, and B1200. So recommended to use the two that are in almost always. ToOs can be done by some visitor instruments, but the availability is more limited. Some of them are block scheduled, or we might not have as many people trained up to use them. So you should check any given call for proposals to see which visitor instruments are available for TOOs. Some of which have done it are Elopeke and Zorro and Igrans. And it's important to know about the policy for competitive TOOs that we developed after the gamma ray burst kilonova. The gravitational wave kilonova follow-up from a few years ago, when we had about 6 or 8 different groups wanting to observe the same thing at the same time. So we developed this policy to make it clear what we'll do in this case. Link is there if you want to study it, but the main points are that the pre-approved Q programs get priority over any director's time proposals that come in. If multiple TOO requests come in for the same target, then if there's time, we'll try to work with PIs to work out what to do. But if there's no time, we're just going to take some data and work out what to do later. But there are some rules, like first TOO in will usually win. And if there are multiple requests for the same configuration, like the same instrument and grading, then we have the option of sharing the data between the people that requested. So you're getting ready to do a trigger, and there's some information you might want to check on our web pages before you do. There are pages that give the TOO status of each telescope. It says whether we're accepting TOOs on that night. For example, there might be classical run or might be a engineering shutdown. So these links down here give these pages like this for Gemini South. These are instruments that are available until what date this notice is good. And then, and then also the 2 GMOSs have pages which give the main components which are installed, mainly the gratings and the slits that are currently in the instrument, so you know what to use for your trigger. Oh, I should also mention that the PDF of this presentation is in the session on Wahova, so you can get the links and use it for reference. Also, you might want to check the weather to see if one telescope might be closed or not, so you can decide where to send your trigger. So there are some links to various useful web pages to get the current conditions, humidity and wind speed, things like that. And satellite images, also with satellite loops, are very useful for seeing if there's clouds for the 2 sites. Often it can be hard to tell from this whether we are open or not, or whether we could observe. So if you're in doubt, just send the trigger and we'll try to do our best to get it observed. Okay, so that's sort of the information you need to sort of send the trigger. Now, I'd like to go through the actual how it's done. So in general, the process is that you have to organize a set of observing templates, and then the process is to apply a target to a template and then submit it to our database for further action. So during the phase 2 process, the contact scientists will work with the teams to define these template observations for the different instrument configurations they're going to use. And they're set to a special status to on hold, which means they've been checked, they're ready to go, but then they shouldn't be touched after that. Then once you have a target that you want to trigger on, the sequence of operations is copy paste this template to make a new observation, fill in the target specific information, of course, the coordinates, position angle, look for guide star, that sort of thing. Put any special instructions in notes, upload finding charts. You set the observation to phase 2 status called prepared, and you sync that with our database, and that causes a bunch of actions to occur in our database. That is the trigger itself. So as you can see with these sort of screenshots, this can be done manually with the observing tool or OT. But it can also be submitted programmatically via this URL API. You see a little bit of the instructions here. So basically, you construct this URL string, which provides information to the database with all the target information and the other target-specific information like I had on the previous page. And the ODB takes care of the copy, paste, and trigger action. And you can get more documentation and some example scripts at this GitHub repo. It's called GSSelect, and we'll be going and using that later on in the presentation. So while not required, because the OT will do guide star search for you, checking for guide stars is kind of recommended to ensure your observation is feasible. Guiding is really needed, like to remove wind shake, do tip tilt corrections, and get the best image quality. And many of the guiders, like the GMOS OIs, have rather limited fields of view, so there might not be a guide star available at all position angles. So if position angle is important, then you especially want to check. This GSSelect script will allow you to do guide star selection outside of the observing tool. It uses algorithms similar to, not exactly the same, but it's the same idea as done by the observing tool. And the bonus is that it has a fine position angle feature, which we've never implemented in the observing tool, which picks the best guide star available and then sets the position angle so that you're sure to get that in your guider field of view. I can show how that works a little later. This API is very useful, but it does have its limits. For one thing, it does not support non-serial targets very well. We use ephemerides for all non-serial targets, not orbital elements. One important thing to know, and with the current API, you can't upload this ephemeris file or specify that this is a non-sidereal target. It assumes everything is a sidereal target. So a few workarounds here in case you're going to use this for non-sidereal targets would be basically in the target, give the horizon's name and give some approximate coordinates to use for selecting guide stars. You need to use PWFS2 for guiding. You could, in the note, you could put the horizon's name and the target type. So then either the observer or the QC could do the horizons query to get the ephemeris and then search for guide stars and so on. And just be sure that the observer knows that it's a non-sidereal target. You could also use the note to put a URL, a link to any ephemeris file so the observer or QC could download that and get it into our system. All right, so that's the end of the first sort of presentation piece. So I was wondering if there are any questions on that part, and then before we dive into the first demo.
Okay, so right now, Bryan, there are no questions currently in the Whova question and answer window, but I will keep monitoring it and let you know.
Okay, and you can interrupt me if needed.
Sounds good.
All right, so we'll dive into actually trying to run some code here in real time and install software. We'll see how that works. So we're going to go through an exercise of actually running GSSelect and doing a trigger. And I'm going to try to do this in real time. So this is the part where you might be able to keep up with me if you've got sort of an environment ready to go. I will try to keep it separate from other things on your machines. You can delete this easily if you need to. So this should all work with Python 3.6 or newer. I recommend using Python 3.7, especially if you're going to go ahead and do the TOM installation a little bit later in the workshop. And so first thing, of course, is just start with some working directory. So I'm here in my Python directory, and I'm going to create a directory here to put everything. And then I'm going to create a Python environment to keep everything isolated from the rest of my work. And activate that. And now I'm going to stall it. It'll take a few seconds to download the dependencies and install everything, but it's at least this part's fast enough. The other thing I'm going to do is download an example script from this repository. That's done. There's that. And the help, the documentation for the API. So now we get into the configuration. This is the example triggering script. So the main things we need to change, personalize it, is that I'm going to set this flag to true. So actually do the trigger, actually set it from on hold to ready. If you kept this ready equals false, it would make the new observation and put all the target specific information in there, but keep it at on hold. So now I've got an email address. So associated with a user key in this one test program I have. So I'm providing the user key. And we have a program in our test observing database at Gemini North. So we can trigger at will in this program. It will not interfere with anything operationally. It only sends me email spam, nobody else. So I'm going to set the server to the Gemini North test ODB. Next, I have to give the OBS ID of the template. So I'm going to show you the program here. Here's my observing tool. Here's the program. These are the different templates which are set on hold. There's some GMOS standard trigger, a rapid trigger, and the spectroscopic acquisition. So I'm going to use one. I'm going to do the standard trigger here. And then all the target info has to be put in. And then, so I am going to actually do this mode where it finds the brightest guide star and sets the PA such that you can reach it. Special mode. Other thing I want to do is that the title of the group, or it will stick the observation just to keep it. Separate from other things. If anyone is following along with this, you are free to trigger, just change the name of the group. Okay, I think that's all right. Just do some checking. All right, let's try it. All right, so it's doing the guide star search. It found one, so it's popping up a little sort of position editor type display here showing the target. There's the guide star, the GMOS field of view. I closed that, and there it sent the trigger. It told me observation 31 was created. So I go to my OT. There it is. Observation. It's got all the information that I put in there. There's the guide star. Observing conditions. Everything that was in my script is now in my observation, and that can be observed. And if I look at it here, there's the guide star. It looks like my other visualization in the Python script. So that's all good. That's a basic triggering with this API. let's go back here. But the triggers can also be done with other layers of software, including these target observation managers are called TOMs, and you'll be hearing about those a lot at this meeting, especially today and tomorrow. So it's basically a web application on top of a database, which allows you to manage targets. It allows you to, enter the targets into your database and then submit observation requests to different facilities. These were first developed for a lot of TDA projects, but they're useful for non-TDA projects as well. Anything, especially with a lot of targets, or you have a large team and you need to manage data access and things like that. They're very flexible. They can even, manage the data processing, the data visualization, the prioritization. And the Las Cumbres Observatory has developed a toolkit which makes these really easy to create and stand up. And the link is here to get them more information. And just a little bit about the context that these are used in. So let me make this bigger. This is sort of the time domain ecosystem which the community has been developing. We'll talk more about this tomorrow, but I just wanted to get the brief overview today. There are facilities that generate alerts. There are brokers like the Antares system we'll hear about tomorrow, which does cataloging and classification, and the TOMs fit right in the middle here, where teams use them to collect the types of objects out of the brokers that they're interested in, and then use the TOM to manage the observations that they have on the facilities on which they have time. All right, so now we are going to actually try to create TOM. I said this was pretty easy to create. I'm going to try to prove it. To install the software, you have to run these various pip commands. They don't take too long, but longer than I want to wait right now. So I've pre-downloaded them and have another environment ready to go, but I am going to go through the creation and configuration of the TOM. So I'm going to start with this. So there's created in that directory, and now I need to start edit some settings. First thing I need to do is add and then I can run this setup. Answer. One for sidereal, it doesn't really matter. Then you need to make an admin account. So add a password. And there, that's the basic is done. But now we need to configure it. So it knows about my programs and I'm available in my access. So again, we're editing the settings.py file. I may need a few settings down here. The main thing is I need to tell it here. There's under facilities, under Gemini, then I have to give it all the similar type of information that I gave in the other triggering script. So I am just going to chop out this whole Gemini section. And you can copy, basically paste this bit right here into there. So as you can see here, I have to give it the URLs for the servers, just like I did before. I've got to give it these keys. I've got the email address and the keys for authentication. And then I've got to tell it about, these templates, the programs, IDs, and the templates that I have with a little description for each one. I'm also installed some sort of special plugins, which I need to tell it about. One is an extra plugin for Gemini. There is a base or a very simplified version of the Gemini plugin that comes with the ToM toolkit, which is fine to use, but it doesn't support GSSelect. It doesn't support the guide star selection, just in order to reduce the dependencies in the ToM toolkit. So I've added this extra repository here, which does allow you to run the GSSelect. You can get it from here. So in order to tell it about that, I need to comment out the built-in one. Tell it about the new one I just installed. And likewise, I installed the Antares plugin for the Antares broker. So I need to basically do the same thing. I think in order to use the Antares broker and the Antares client that connects to it, you need to email the Antares team to get API credentials, and the instructions for that are here. So that's probably something you won't be able to do right now. All right, so I've got the configuration file up to date, and now I can actually apply that by doing this migrate command. And then actually run it. Okay, so I can then go to it. And there's my ToM. I can log into it and I'm ready to go. That's it. I've got a customized ToM in like whatever, that took 3 minutes. So there really is pretty easy, and there are all kinds of course complications, extra things you can do. This is just the start, but we can have a little look around. There's a place to enter targets, so you have a little map of the sky. You can create targets manually, import targets from lists, do like Simbad searches to enter them. Of course, the power of this is to do queries on these brokers. So that's what we're going to start with. So a bunch of different brokers that you can connect to. I'm going to use this Mars broker, which has a ZTF alerts that was managed by Las Cumbres Observatory. So I'm going to search for one particular ZTF target that I know about. I'm going to call the query that, and I'm going to look for this ZTF object ID. So I submit that. So that created the query. Now I'm going to run the query. It's Mars broker. So here's all various events for that target. And if I click view here, then it opens up the Mars broker, and you see there's the object. It looks like some sort of merging galaxy with sorts of tidal tails and shells, with maybe some sort of variability in the center, maybe AGN. Now let's try to observe that. So we go back here, we need to put it into the database. So I'm going to select it there and create target. Do this page and I just save it. So there's the observation in the database, the basic info. You've got the view of it. And now I'm going to want to observe it. So I'm going to go to the Gemini tab. This brings up the form for doing the manual observation submission. So first there's an elevation plot here, and we can see these are the different sites that it knows about. And this is setting very early in the night at Mauna Kea, so it should be observable. So here is the form. You can fill out all the parameters for the target. You can enter the guide star manually if you want to, or it will do the search. So this is sort of what I will do. I'm going to actually do a rapid trigger now. Give it on the group name. I'm also going to use this find position angle mode. It's about 18.7 magnitudes in brightness. I'm going to give it an air mass constraint so it can go a little lower than the normal. I'm going to update the exposure time. Yeah, I could enter a note there. So now let's just try this out. Oh, another thing I want to do is I actually want a P2 guide star instead of OI guide star for this one. So let's submit. Again, it's going off doing the guide star selection right now. There, I think something happened. And there's the observation entry in the database. See, here's the observation that was created. It gives the observation ID here. Go over here. This was actually a rapid. So this is the pop-up that the observer gets when there's a rapid TOO. So I can view the observation, see if I need to do anything with it right now. And there it is. There's the P2 guide star. I've got my air mass constraints. Changed my exposure time. All looks good. All right. So I think we are now down to, yeah, there's the results. So that's basic manual triggering with the TOM. Of course, advantage of this is that you can do a lot of automations in the TOM toolkit. It has, of course, APIs, so you can actually control the TOM toolkit from external scripts, including Jupyter notebooks here. So I can go through a little example of that. I've got my notebook running over here, so I can just go through. And this is going to do a query using the Antares client. There's this particular target I'm interested in, so I'm just going to query for that. And go down here, there's some information about it. I'm going to, and then here's sort of in code, this is sort of like our first script we looked at of defining the details of the observation. Is basically a way of programmatically filling in that form in the TOM. So I'm going to tell it to use, it's this northern target, so it's going to use these two observation IDs. This is the standard science observation plus the acquisition. I give the target information. I'm going to do exposure times, various notes, air mass constraints. That validate looks good. And now we actually submit it. There's two got submitted, and I'll just enter those two into our database. Keep track of it. I go over to the OT. There, I've got the two observations. That's the science and the acquisition. So multiple ways of triggering with TOMs, and it's the automation that makes it really powerful in conjunction with querying the brokers. So we've triggered a whole bunch of observations. We're hoping to get a lot of data. Then once we get data, we actually want to get the data out of the archive, hopefully do that in a programmatic way as well. And there are APIs to do that. I'll go over just briefly a little. I'm not going to go on much of this, just for information and some references so you can look up more information. The archive has RESTful APIs, which allows you to do things like doing searches, downloading files, looking for calibrations and things like that. So it's just one example of a query you can do, and some other potentially useful information, various libraries you can use. This URL gives the documentation for those APIs. And these are used now to make the GOA accessible via Astro Query. So take a look at this link for instructions for that. That can be extremely useful. Also, a couple of years ago, while I was playing with these APIs, I wrote this other little Python library, which mainly is like the communication boilerplate you don't want to repeat all the time. So that might be useful to some people. So it's available here. And this old presentation from a workshop on the ToO toolkit gives some examples of how to use it. Okay, so that is ToO triggering on Gemini now. So before I go on, it'd be a good time to stop and see if there are any questions.
Okay, let me refresh my Whova window, Bryan. My window is giving me a blue thing.
Yeah.
If Joanna can hear my voice, Joanna, are there any questions in the Whova Q&A?
No, I don't see any.
Excellent, thank you. Please continue, Bryan.
Okay, very good. Since actually I think we're doing pretty well for time, I am going to go backwards a little bit and do one other example with the Tom to show, again, using Antares. So I'm going to actually use this Antares plugin that I installed and just show how that can be used. So I'm going to call this query Nova test, and this is going to use a filter that Monica, who'll be talking tomorrow, made. Define all these have been defined under tags, and Nova test filter, which that she explained to me is designed to find things that are getting bluer in time. The light curve gets bluer in time, so it's designed to try to pick out supernovae. So I'm going to make that query, and then I'm going to run it. Takes a few seconds. You can get a lot more information on the Antares website about how to create these filters. Okay, there's the list. Now we can look to see if there's anything useful here, anything interesting. So you get nice light curves like this. So that might be something that, you know, an interesting supernovae. So the triggering process would be the same as before. Create the target and so on. I just wanted to show that the Antares query in action. All right. All right, when we finish up by describing a little bit about the future of targeted opportunity at Gemini. And we'll go over sort of the bigger picture of this tomorrow, but a little bit some of the more details of what we're planning for in the next few years. We do want to improve our ToO capabilities as part of the ongoing Gemini Program Platform and the Gemma projects. These are major software efforts to try to make proposal and phase 2 preparation just much easier. Basically, we're going to be replacing the phase 1 tool and the OT and most of the other high-level tools. Really, we need to add new features that are just not possible in the current code. And by doing this, we allow a lot more automation. The key is making the system more API driven. It also allows us to make the code more maintainable, scalable. We're going to be producing an automatic queue scheduler to handle the scheduling part of it, and there's real-time data reduction, and we'll go over more of that tomorrow, and you heard some about that from Kathleen today with Dragons. And there's more information in these Gemini Focus and the NOIRLab Mirror newsletters. So the fundamental improvement for time domain is to make all the relevant information accessible via APIs. We don't want any more of having to go to web pages and look at them, or try to scrape them into a script. So everything from the telescope status, instrument components that are available, the weather, information about your programs, all has got to be accessible easily programmatically. And it's going to be possible to basically do everything programmatically that you can do with the UIs that we're also developing. So all these sort of things, you can query configurations that match requirements. That's one of the main concepts that we're building up. As you can see right here, the idea is that you enter, for example, spectroscopy mode at a certain wavelength, a certain resolving power, a signal to noise, and we'll give you a list of all the Gemini instruments and modes which meet those requirements, and you can just pick them from there. So you don't have to go digging through lots and lots of instrument web pages. You'll be able to run the ITC. That's going to be fundamental part of all of this. Running the guide star queries, basically replacing that GSSelect script, would just be built into the system. Be able to create, modify, and submit and retract the observations programmatically. You won't have to go into the OT. There's really almost no way to retract an observation now without just emailing the QCs and saying, oh, I don't want to do that anymore. Another fundamental concept is it shouldn't be necessary to create these on-hold templates. I think it's maybe possible to still do that if you want to, but the idea is that you'd be able to create observations from scratch using our automation. And of course, we'll have full serial target support and uploading, downloading all the attachments, such as the ephemerides, mass design files, finder charts, all of that will be supported. Now, the native APIs that will be used by the UIs, which is these, is a system called Graphql, which is very flexible and is very useful for these web applications. But it's a little different syntax than sort of RESTful APIs that we're used to, like is used now for the archive and the API for the database I showed earlier. So we're going to have to do some training and things to help people out to get going with this. Giving examples, maybe developing some Python libraries to make some things easier to use, and give you some canned queries that are used very frequently. There'll be a new TOM Toolkit plugin, which will hide all this detail, so it'll look basically the same as it did before. And we'll be in discussions with Las Cumbres, we're working with on Aeon, as I'll talk about tomorrow, to try to develop some standards so that people learn the system once, you learn an API once, and it'll be applied to a bunch of different facilities. So we're hoping to start early testing on that next year and get the whole system operational by 2024. So it's still a few years away, but there's a lot happening on it now, and keep an ear open, keep an eye open for opportunities to test this out. And with that, that's basically it. Just in summary, the current TO trigger process is just based on adding targets to these template observations, a manual mode and this programmatic mode with the sort of basic API. But you can do a lot with it. There's a TOM toolkit that's very flexible, lots of different ways to automate it even with the existing limited APIs. in the future, we're going full API. I mean, programmatic access is the way to go. Automation and doing all this stuff without a lot of manual interaction. That's the only way probably the community will be able to handle a lot of the increases in alerts that we're going to be getting, and to do things rapidly. For example, if you have gravitational wave follow-up or fast radio burst, something like that. So that's just the low-level stuff. We'll talk more tomorrow about sort of higher level and go in some different aspects of what I mentioned here. So, but I'm willing to take any questions.
Excellent. Thank you so much, Bryan. We do have a question here posted by Monica. Monica asks, is there any plan to integrate dragons with the ToM?
It could be. I think I know that various groups who are using ToMs use the ToM to manage their data reduction. So I would imagine, given that Dragons is Python, it ought to be straightforward to integrate those. We don't have any plans to do it yet, but a science team should be able to do that. Or it's something we can try to help out with down the road.
Okay, let me refresh one more time and see if there are any additional questions. Okay, I don't see any additional questions, Bryan, but you do have 12, 13 more minutes if you'd like to continue to add anything else.
I think I've covered all I've prepared. And so we can end a little early if there are no other questions. I've also got sort of chat times tomorrow. If anyone wants to talk more about this or needs help with running some of the software, getting things configured, so please sign up.
Thank you so much, Bryan. Bryan Miller. Okay, so if you have not signed up for Bryan's chat session, please make sure you do that so that he can answer any additional questions you may have. Excellent presentation, Bryan. Thank you so much. And with that, I will send it back over to either Janice or Joanna.
Well, thanks everybody. And thanks, Bryan, so much. And we'll see you back here tomorrow for day 4. And don't forget the picture after the panel. Be prepared to turn on your video. Have a good evening. Bye-bye, or morning.